Okay, so in our last video, we looked at solving exponential equations. And in this video, we're going to focus mostly on solving logarithmic equations. Okay, and one key piece that we need to know is that logarithms and exponentials, those are inverses of each other. So let's take a look at an example here. And let's say we have log base 2 of the quantity 5x minus 17, and that's 17, and we're going to set that equal to 3. Okay. um, to solve this, you could think about it two ways, and some of you have said that each way makes sense to you, so I try to present both of them to you. Mathematically, what you could do is you could say, all right, so to undo a logarithm, I need to have it as an exponential. So I'm going to say 2 to the power of both sides. So that would undo the logarithm. And so I would be left with 5x minus 17 equals 2 to the third, or 2 to the third is 8. Okay. Um, the other way you could have thought about it, and some people like this method a little bit better, I call it the circle method. I don't know if this is actually a mathematical method or not, but you start with the um, 2 and you kind of go in a circle. So you'd say, oh, 2 to the third, 2 to the third, and you just kind of go in a counterclockwise circle equals 5x minus 17. 5x minus 17. Okay? Either way, gets you to the same place. From there, let's just go ahead and solve because our ultimate goal is to get x by itself. So I'm going to add 17 to both sides and get 5x equals 25, or x equals 5. Okay? We could plug this x equals 5 back in, and you should see that yes, this would work. Okay, you could check your answer and say, hey, does the log base 2 of 5 times 5 minus 17, does that equal 3? Well, 5 times 5, sorry, I'm getting a little sloppy here. 5 times 5 is 25 minus 17. So does log base 2 of 8, does that equal 3? And if you plug that in a calculator, log base 2 of 8, it does. So our answer works. Okay. So that's kind of our baseline example. If you feel like you can solve something like that, you're probably at a level, let's say level 2, if we're going from 1 to 4. Okay. We're going to get a little bit trickier here, and we're actually going to involve some of the properties we've been talking about in the last week, so some properties of logs. So our second example, we're going to say the log of 2x, and then we're going to add the log of the quantity x minus 5 and set that equal to 2. Okay? And the first thing we need to remember is that if you are adding two logarithms, we can put them together in one logarithm and just write it as a multiplication statement. So the 2x times x minus 5. So 2x minus, or times x minus 5. Okay. Again, if they don't write anything, just assume it's log base 10. And we haven't done anything to the right side, so that equals 2. Okay. Now I'm going to distribute this 2x to both terms. So 2x times x would be 2x squared. And then the 2x times negative 5 would be minus 10x. Okay. Log base 10, and it still equals 2. Okay. Well, now let's get rid of the logarithm. Again, our goal is to get x by itself. So to get rid of the logarithm, we can raise both sides to the 10th power, and that would undo, all right, we say 10 to the log base 10, and that would undo that. So we're left with 2x squared minus 10x equals 10 squared, right? This is 10 to the second power, or 100. Now this step, we're actually in pretty good shape right now. This is simply a quadratic. So to solve a quadratic, I'm going to try and see if we can factor. So I'm going to set my equation equal to 0. So I'm going to subtract 100 from both sides. 2x squared minus 10x minus 100 equals 0. And I notice that they are all even, so I'm going to factor out a 2 and say this is x squared minus 5x minus 50 equals 0. And you can actually divide off this 2. Okay, let me give us a little more screen here. And so just to finish up, well, x squared minus 5x minus 50, this is just a reminder, how do we solve some quadratics, equals 0. So we have to ask ourselves, what are some factors of negative 50 that add up to negative 5? So some factors of negative 50, I'm going to pick negative 10 and a positive 5. So you can write this as x minus 10 and x plus 5. And if you want to check me, make sure I did it right, go ahead and FOIL it out. You can. Equals 0. And so your solutions are x equals 10 and x equals negative 5. Again, just set x minus 10 equal to 0 and x plus 5 equal to 0. And in this case, you actually have two solutions. Okay, so that's solving logarithmic equations. Again, just to recap that problem, we had to remember that there was the property of logs. If you are adding two logarithms, I said we're adding two logarithms, you can write it in one logarithm as a multiplication statement. Okay, the multiplication statement. And from there, then it was just undoing a logarithm by making both sides an exponential to undo that log.